All right, let's take a look at this lesson on sequences and series. So let's get some basics down. So let's talk about what is a sequence. So a sequence is a list of terms. It's a list of terms. Okay, so what is a term? A term, these are the individual entities. We'll be working mostly with numeric sequences like -4, 8, -12, 16, so forth. So those are terms. That's what a term is, the function value. So the a sub n term, what that is the formula. It's the formula that generates the terms. That's what an a sub n formula is. It generates the terms. And we'll look at some a sub n formulas. So a finite sequence, finite means that it ends. It doesn't keep going forever and ever like an infinite sequence. So a finite sequence basically stops. Okay. If the sequence consists of the first n positive integers only, that's what this means. It stops, right? So at some particular value, maybe 10 terms or maybe 20 terms, but it stops. Okay. Sequences usually begin with a sub 1, but sometimes they begin with a sub 0. Just so that you're aware, it's okay to begin with a different sub number, a sub 1, a sub 0. And so our notation, we have to show the nth term. We have to show the nth term. And the nth term is, this formula. That's what the nth term is. That's our notation. Okay. Let's see, what else? It means a function whose domain is the set of positive integers. These numbers, the sub-numbers, are the domain. That's the domain. And it starts with either a 1 or a 0 and continues as long as the sequence continues. Okay. So let's go over a few other things. We need to talk about factorials. Now maybe we remember factorials, maybe we don't. It starts with an exclamation point. That's a factorial. And so, for example, 4 factorial means 4 times 3 times 2 times 1. You basically start at that number and then multiply everything in sequence all the way down to a 1. The only very strange one is 0 factorial, and we just have to know that that's 1, just in case you encounter 0 factorial. Okay, so let's look at our first example. We want to write the first 5 terms of each sequence. And so this says that n, these are our term numbers, n is the term number. That's what n is. And what we're going to do here is we're going to change this to 3. We're just going to do 3 terms because I think you'll get the idea with 3. Okay, so here we're going to start with a 2. So a sub 2 would be 2 minus 2 factorial over 2 factorial. Okay, we just plug in a 2 where the n is. And so that's going to be 0 factorial over 2 factorial. And we just looked at 0 factorial, that's 1. And 2 factorial is 2 times 1, or 2. And so that's our a sub 2, which is actually our first term, because it says start at 2. A sub 3 would be our next term, so we're going to put a 3 where the n is. Okay, so that's going to give us, let's see, 3 minus 2 is 1, so 1 factorial over 3 factorial, and 1 factorial is 1. 3 factorial is 3 times 2 times 1, which is 6. Okay, fantastic. Now our third and final term, which happens to be labeled term number 4, sub 4, but that's actually technically our third term. So here we go. We plug a 4 in. 4 minus 2 factorial over 4 factorial. That's 2 factorial over 4 factorial. Now I'm going to show you, let's kind of expand this out. As they get larger and larger, it becomes easier if you do this expansion to simplify. So that would cancel with that, and I'd be left with 1 over 12. Okay, those are our first three terms. Let's do the same thing for number 2. This one begins with a sub 1. So a sub 1 would be 2 to the 1 minus 1 squared. So what is that? 1. Okay, a sub 2 would be 2 to the 2 minus 2 squared. And that would be, what's that? 4 minus 4 is 0. And our third term would be 2 to the third minus 3 squared. So that would be, what, 2 cubed is 8, 3 squared is 9, so that would be a negative 1. Okay, so hopefully we get the kind of idea about how to generate terms. This again, let's highlight this. This is called our nth term. These are nth term formulas. They generate all the terms. Okay, so let's go down to this number 3. Okay, so we want to find the next three terms. Notice that they did not give us an nth term formula. Now, at some point, we probably would need to learn how to do that. Right? That's in the next few lessons. But here, we're just supposed to generate the terms. So this is term number 1. This is term number 2, term number 3, term number 4. Okay. Notice that it goes minus, plus, minus, plus. So the signs change. So let's talk about how to make signs change, what little formula that we use. And actually, it looks like we need to write the nth term here. So we'll write the nth term. So negative 1 to the n. So that's if our n starts at 1. Okay, if our n starts at 1, negative 1 to the n. This would start with a negative number. Because I put a 1 in there, I get negative 1 to the first, that's a negative number. Okay? If we do negative 1 to the n plus 1, so I put a 1 in there, 1 plus 1 is 2, negative 1 squared is positive. This configuration would make us start with a positive number. Okay, so this is the configuration to write formulas, or a sub n formulas, that the terms alternate. Let's see, we're starting with a negative number there, so let's use that first little, negative 1 to the n. That'll make us have a negative number. And let's see if we can figure out the pattern. From 4 to 8 to 12 to 16, let's see what's happening there. 4 times 1 is 4. It looks like multiplying by, so these represent n, right? 1, 2, 3. Let's see if this works. 4n. So 4 times 1 is 4. 8 times, let's see, 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. So this would be our nth term formula. Okay, so let's write the next three terms. So the fifth term, let's see, so this one would be a negative, and 16, so that's 4. So 4 times 5 would be 20. And the sixth term would be positive. 4 times 6 is 24. And the seventh term would be negative. 4 times 7 is 28. And those would be, that's our nth term formula right here. And those are our next three terms. Okay, great. Let's do one a little bit more complicated with fractions. Now, when we have fractions, it would be very beneficial or advisable to do the numerator separately from the denominator. So let's look at the numerator first. So we start out, our first term has a 2 in the numerator. Our second term has a 4. Our third term has a 6. And our fourth term has an 8. Okay, so how would we use in this term number to generate those numbers. Let's think for a second. So let's see, a sub n equals. Okay, so 2 times 1 is 2. 4 times 2 is 8. So we can't, so 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Oh, 2 times 4 is 8. So this would basically be 2n on top. That's what that would give me. Okay, so now let's deal with the denominator. And so our first term is a 3. Our second term is a 4. Our third term is a 5. And our fourth term is a 6. Okay, let's see. So using a 1, I get a 3. Using a 2, I get a 4. Let's play with this. So let's see, using a 1, I get a 3. So let's try plus 2. 1 plus 3 is 2. 2 plus 2 is 4. 3 plus 2 is 5. 4 plus 2 is 6. Okay, so this is our nth term formula. Great. All right, so that means that, so this is my first term, second, third, fourth. So for my fifth term, I would do 2 times 5 and get a 10 over 5 plus 2 is a 7. Okay, great. My sixth term, I would do 2 times 6 and get a 12, and 6 plus 2 is an 8. My seventh term, I would do 2 times 7 gives me a 14, and 7 plus 2 is a 9. Yay! Okay, good. So now let's go to the next page and let's look at different kinds of sequences, and we'll get more detail into these in later lessons. So an arithmetic sequence is a sequence whose terms have a common difference. Okay, so let's see. What would I do each time here? Let's see, I would subtract 2, I would subtract 2, subtract 2. So the rule would be subtract 2. Okay, that would be the rule there. Here I would, what would I do? So 3 is 6 over 2. 6 over 2 to 5 over 2, I'd subtract a half. 5 over 2 to 4 over 2, I'd subtract a half, and so forth. Okay, geometric has to do with ratio is multiplying and difference is subtracting. Okay, so those are our differences. So let's see. So what do I do to get from a 5 to a 15? I multiply by 3. Multiply by 3. To get that, to find the r, all I'd have to do, which is a common ratio, it's called r, like take the second term and put it over the first term. Or take the third term and put it over the second term. As long as you do 2 in a row, they're just going to come up with the same thing every time. So this would be an r of 3. Okay, so let's look at these and figure out if we can state it's either geometric, arithmetic, or it doesn't fit either of those models, and so it would be neither. Okay, and if it is arithmetic, we want to find the common difference. If it's geometric, we want to find the common ratio. Okay, so let's figure this out. All right, so this is actually number 5. A little bit of a typo. Okay, so let's check these out. Let's see the difference between these. So 16 plus what will give me 24? That would be what, 8? This difference, 36 minus 24 is 12. Okay, so this is not arithmetic. Okay, it's not that. Let's try geometric. So 24 divided by 16 reduces to 3 halves. 36 divided by 24 reduces to 3 halves. Oh, okay, so this is geometric. And the ratio would be 3 halves. Okay, very good. Let's take a look at this one. Okay, so 4 minus 1 is 3. 5 minus 4, 9 minus 4 is 5. Okay, so it's not arithmetic. All right, let's try the dividing thing. 4 divided by 1 is 4. 9 divided by 4 is 9/4, so it's not geometric. Those would have to come out the exact same for it to be geometric, just like on the previous example. So it's not arithmetic, it's not geometric. That means that it's neither. So this is one of the neithers. All right, so last one. All right, on this last one, we want to look at the difference between the terms. Let's see, 23 minus what would give us 17, -6. 17 minus what would give us 11, we'd subtract 6. Okay, great. So this is arithmetic. And our D value would be a -6. So it's arithmetic with our D value a -6.